Welcome back to our study of inverses. And just to remind you again, in order for a function to have an inverse, like this function f of x, it must be 1 to 1. 1 to 1 meaning for every value of x, there's one y, x1, y1. There's one and only one y value. If there's more than one y value, or say if there's the same y value for two different x values, then the inverse would not exist. Okay, because remember what the inverse has to do. It has to take the y value as input and return one x value. So an inverse function, for a function to be an inverse, well, it has to pass the vertical line test, so it's actually a function. For it to be a function, when you plug in an x to it, you get one and only one y. So it has to survive the vertical line test, and also it has to pass the horizontal line test. So horizontal line test, this function would do that, but imagine if the function wrapped around like this. If it did that, then what would happen? Well, there wouldn't be, then you can see here there's two values of x, x2 maybe and x3. These have the same value of y. So if I tried to create an inverse and I plugged in this y value here, y2, what would the inverse return, x2 or x3? See, it wouldn't work. You couldn't work that way. So inverses have to be 1 to 1. They have to pass horizontal line test. Okay, now back to our study then of the most important functions that we're adding, at least as far as, as the amount of problems that use them. And the first one being, let's talk about e to the x, or it's just an exponential function. This is one of those functions I said that you needed to know. Remember at the beginning of the year, there's a video right at the beginning of the year said functions you should be able to know and be able to graph. So you should be able to take this function, and you should be able to translate it to the right, translate it down, right? I could add a y value, move it up and down, move it left, right by changing the x value. You could scale it by a constant. If I put a 2 out in front of here, you would know what that does also. Okay. There's some properties of exponents that always trip people up that I'll just write down here. As I look back at this, I see that point's wrong here. When we fix that, that's not 1, 0, is it? It's when you plug in a 0, you get 1 right there. Okay. Properties of exponents then. Remember, E is just a number like 2.716, ... Special Euler's number. E could just as well be 2 or 3 or 4, but we'll use E a lot, so I'll just focus on that one. Everything else works like that. If I go A, but E could be A, or I'll just write it like this, though. E could be 2 or whatnot. E to the x plus y is equal to what? Well, that's e to the x times e to the y. And what are these properties? Of exponents. You've learned these before, but again, I'm just telling you from experience, people lose a lot of points. This is what going to be e to the x divided by e to the y. Okay. How about e to the x times y? What's that equal to? You guessed it, e to the xy. And finally, if I have e times, I don't know, e times a, to the x, that's merely going to be e to the x times a to the x. Okay, now if I wanted to get a graph of not e to the x, but say 3 to the x, what would 3 to the x look like? Well, 3 to the x would go up faster, right? Because 3 is bigger than 2.7, but they're all going to hit here. This could be, this curve is 3 to the x. What if I did a 2 to the x, though? A 2 to the x is less than e, so a 2 to the x would come out beneath it. They're all going up to infinity, though, 2 to the x. They're all racing up to infinity as x gets larger. And they all, notice, all of them, this doesn't really flatten out at all. That's, as x goes to minus infinity, these things are all going to 0. So the limit, for instance, as x goes to negative infinity of e to the x is equal to 0. That's going to be the same thing if that's e, or if that's 2, or if that's 5. Any kind of exponent, it's going to be 0. The limit as x goes to infinity of e to the x is also infinity. Notice actually the slope of these functions is always positive. So the derivative is always positive. In fact, the derivative of e to the x is a very interesting thing. And we'll get to that soon enough. E to the x is infinity. 2 to the x would be infinity. 4 to the x would be infinity. Okay? So you understand these pictures. You kind of understand where they go through 0, 1. They go up to infinity. And they go up fast also. Okay, next let's take a look at the log function. Okay, we're back looking at the natural log function, and as you can see here, it starts at 1, at x equal to 1, it's equal to 0, and then it does go up with a positive slope, but it starts going to infinity very slowly, okay, very slowly, but it does get there. And you study that in BC calculus, how fast it gets to infinity, but the limit as x goes to infinity of the natural log of x, that is infinite, believe it or not. It gets up there soon enough. If you take the natural log of e to the 100th power, what is this? The natural log of e to the 100th power, which is a very, very big number, right? E to the 100th power, you'd say that's 100. It's, not too large, but eventually, if this gets big enough, this will go to infinity. Okay, what about over here? What's happening here? Well, the limit as x goes to 0 from the negative side of the natural log of x is equal to what? Negative infinity. So it goes down to negative infinity. The natural log is only defined. The domain of the natural log, domain, or of any log function, is x greater than 0. Okay? X is greater than 0. Okay, there's a bunch of, the natural log is the inverse function of the exponential. There are properties of logs too. These properties make answers. You can write log answers in an infinite number of ways, but let's say the log base, and what the natural log is, again, it's really the log base e of x. They're equal to each other. The log base e. So I could say the log base e of x times y is equal to the log base e of x plus the log base e of y. And you've seen this before. Okay. The natural log, the ln now, these are the same thing, right, of x divided by y is equal to the natural log of x minus the natural log of y. What if I had the natural log of x to the eighth power? Well, I use that up here, actually. That's the same thing as saying that's a times the natural log of x. Okay? Actually, this property was the fact that these are inverse functions. Okay? So remember, I'll remind you once again, I'll give you that picture of an inverse function just so you see it and get some intuition. If I take x through the exponential function, and then I pass it through the natural log function, I'm going to get x back. That's what I did up here. That's what was going up here. I put in 100. I got out right here. I got what? E to the 100th power. I put e to the 100th power through that, and I got 100 back. Okay, these are inverse functions of each other. We will very quickly know how to take derivatives and how to integrate these functions. Okay, I think that's it for the setup. Again, this is like, these are functions. Be able to draw these functions. Okay, this function here should be able to shift it up, shift it left or right, shift it down. Maybe it's somewhat instructive. We don't use these functions as much, but this is log base e. If I did a log base 2 would be what? If I'm out at 2 is going to log base 2 of x. Does that work here? Because here I know at 2, when I put in a 2 to this guy, I get 1. So this is 2, 1. But when I put in 2 into the natural log, I get less than 1. This is going to be 2 times the natural log of 2. Okay, so there's the natural log function. The log base 2, log base e. What about the log base 10? What would that come in? Well, log base 10 would be down here even farther. I'm exaggerating the differences here. But they all have to go to infinity here at the same way. But this one would be the log base 10, which will show up in some science and engineering applications. Okay, there you go. We're done with the introduction here. Next, let's start doing calculus with these functions. How do you take the derivative of these functions? How do you integrate them? We'll see you soon. Bye-bye.